Hi, Dr. Revis here with Watch Me Work It. Hess's law calculation of delta H of reaction. Watch me work it. Here's the problem. What is the enthalpy delta H of the following reaction when calculated by Hess's law? And we have a balanced equation here. And so this balanced equation is our target equation. I'm just going to write the word target here. The target, or occasionally you'll hear me use the term base equation. So this is what we're after. And what we'll do is rearrange the equation from the standard table to get this equation and then calculate our delta H for this reaction. So here's how we do it. All right, so let's start. We start by identifying one of the reagents in the base equations. I'll start from left to right. Why not? OF2. And so if I go down to the standard tables, I am looking for an equation that has OF2 in it. And I see it's the second equation here. There's my OF2. So since I have OF2, what I'm going to do is rewrite that equation exactly like it is. Why? Because I have OF2 on the left side equation. It's on the left side here. So I'm going to regenerate that equation just as it exists. No changes. I'm just going to leave the states off for now. And we'll just rewrite this equation. The goal is to get these equations aligned to look like the base equation. And since I wrote that with no changes, I'll repeat writing my value of delta H. All right, next I go to the next species. The next one's sulfur. I look for sulfur in one's equation. Here it is here. And it's on the left side, so on the reactant side. It is a reactant. Therefore, I'm simply going to rewrite it just as it exists. No changes. I'm just leaving the states off just for convenience. And since I simply rewrote that equation, I will go to here, nope, right here. Get the value from here, and that's 296.9, and I write it. Next, I move to the other species. I see I have SO2, but by observation, I see I have SO2 in two equations, the first one here and this one, so I'm going to skip it for now. When I find that to be the case, I tend to skip the one where it shows up in many equations. I go to the other species and see how it works out. So I'm going to skip and go to here. SF4. So I have SF4. Here it is. In the case of SF4, in the base equation, it's on the product side, on the right side of the arrow, on the right side of the equation. In the case of the standard table, it shows up, where's SF4? There it is, on the reactant side. Therefore, I have to flip this equation. So when I flip the equation or reverse the equation, what you do is rewrite the equation from the standard table in reverse order, and I tend to just write it just like this. Write your products, what used to be the products, turn them into the reactants, and then you'll have your reactants that you turn into the product side. Make sure you don't lose anything in your balanced equation. You'll need those, H2O. And then since I reverse or flipped this becomes a positive now. So this is a plus. I'm just writing a plus so I can keep track of it. It's a positive number, 827.5. Now what I would like to do is add these equations to equal the base equation. So if that's the case, I need to go back up now and check my balancing. And I notice that the OF2 has a 2 in front of it, and I don't have a 2 in the equation I'm writing here, so I have to put a 2 outside of here, so that's 2. And so I multiply 2 times everything. You can rewrite this over and over again. I tend to be able to visually see it without putting the 2's distributed through there. I just write them. But then I want to make sure I multiply this time too, so I'm going to rewrite it outside here so I don't lose track of what I really want to add up. Next, I go down to my next equation. I notice that I have sulfur here, and there's a 2 in front of sulfur. And here I only have 1 sulfur, so this equation needs a 2 also. I'm going to not distribute it through because I can visually see that. If you need to, just distribute it all the way through. But I definitely want to write this number down so I don't lose track of it. Since I multiply times 2, everything gets times 2. Those are just the rules of math. Okay, the next one I look at SO2. Since I see that in several places, I'm just going to leave it alone for right now, and I'm going to check out my SF4. I have 1 SF4 and 1 here, so I'm probably in pretty good shape. All right, so when I do that, then that means I simply rewrite this number here, 0.5. Now I'm going to add these up, but what you want to do is one more step before adding it up, but since I feel really good about having balanced it and I can see it without distributing it through, I have a lot of confidence in this number. But I want to make sure this number makes sense though. So let me just check that number. So what I do to check to be sure I've done this properly is I look for it to see whether or not I really did make my new base equation. So here's what we're going to do. We're going to look for things that we could cancel. Here's what we observe. We have water on the left side, and we have water on the right side of this one, so they cancel out. Those are the rules of math. Opposite sides cancel out. Essentially, we're going to add these up. You could add this in one long equation and do this calculation, but that just gives me too much clutter for me. So I just do it visually by going through here. I check the next one. I have 2 sulfurs. That works out pretty good, but I noticed my oxygens. I have 2 oxygens, so look like the oxygen is going to cancel out here as well. Notice also here with the SO2s, I have 1 SO2 here, and here I'm going to end up with just 1 SO2 left on this side when I cancel. Again, you cancel left, right. Those are rules of math. That's all we're doing is using rules of math to do these cancellations. And also right here, these cancel out. There's 4 and 4. So when I do that, I do see that I have the equation. I do see I have my OF2 left over with a 2 in front of it, plus 2 sulfurs on this side. Everything else is gone. I have an arrow here, and I'm left with SO2 here, plus SF4. So I feel pretty good. Yep, I was right when I did this. This is my answer. It's exothermic reaction because it has a minus sign to it. So that's how you do Hess's law calculations of heat of reaction.